Welcome to chemistry classes. In this video we are going to discuss about chemical reactions of phenol. Chemical reactions of phenol. We know structure of phenol. Here benzene ring, on the top of benzene ring there is OH. We know oxygen atom, there is 2 lone pair electrons on the oxygen atom. This electron pair will be conjugate with pi electrons of benzene ring. We already discussed this type of conjugation. Here electron pair, it will conjugate with pi electrons of benzene ring. Okay, and here oxygen carbon oxygen getting a partial double bond character after a series of resonance structure. We know there are a series of resonance structures possible. We already discussed previous videos. You can check previous video these things. Okay, after a series of resonance structure, ortho and para position getting a negative charge. Okay, here ortho, this two position are ortho position and this is para position. Okay, so here electron pair in the oxygen atom, it will be conjugate with pi electrons of benzene ring, and ortho para position will be deactivated by OH group. Okay, or we can say ortho and para position getting negative charge. So during chemical reactions of phenol, ortho and para position get substituted because here ortho and para position they have negative charge. So electrophilic substitution reaction, during electrophilic substitution reaction, here ortho and para position get substituted. Clear? So here based on this information we have many substitution reaction, many chemical reactions we have to discuss. So all are ortho and para position. Ortho and para position getting substitute. Okay, why ortho and para position getting substitution? Because here this OH, here oxygen, there is electron pair. This electron pair will be conjugate with the pi electrons of benzene ring, and here ortho and para position getting negative charge. That's why here substitution happening in ortho and para position. So here electrophilic substitution reaction, a mixture of product will be formed in most of electrophilic substitution reaction. So we have here nitration, halogenation. This type of chemical reactions are electrophilic substitution reaction. We are talking now electrophilic substitution reaction. So these electrophiles are substituted on ortho and para position, and we will get a mixture of product. We will get one ortho product and one para product. We will get a mixture of product. Clear? So here first chemical reaction we have to discuss here, nitration. Nitration mean here phenol react with dilute nitric acid at 25 degrees Celsius or 298 Kelvin. So we will get ortho nitrophenol. Look here, this is ortho position, ortho meta para. Okay, so here ortho nitrophenol and this is para nitrophenol. So after nitration we will obtain a mixture of product, ortho nitrophenol and para nitrophenol. Okay, so we will obtain a mixture of product. From this mixture we can separate ortho nitrophenol and para nitrophenol. We can separate by steam distillation. We will use steam distillation. To separate isomers of this product. These are isomers. Okay, so ortho nitrophenol and para nitrophenol can be separated by steam distillation. Clear? So we will use here steam distillation. Okay, so look here, this is ortho nitrophenol. Okay, so here OH and here this is ortho position, there is NO2. Look here, NO2, we can do it like this, nitrogen double bond, single bond oxygen. This is NO2. Okay, so here here this is NO2, here oxygen it is partially negative charge, and OH hydrogen is partially positive charge, and there will be a weak bond formed between partially positive hydrogen and partially negative oxygen, and this bond is hydrogen bond. Okay, here hydrogen bond formed in same molecule, or hydrogen bond within the molecule. Okay, hydrogen bond in a molecule, such type of hydrogen bond called intramolecular hydrogen bond. Okay, so here this is intramolecular hydrogen bond possible in orthonitrophenol, but same time here this is para-nitrophenol, here OH, and this is para position, here NO2. In para-nitrophenol, here this is one molecule and this is another molecule, and this is hydrogen bond. Okay, so here in para-nitrophenol, intermolecular hydrogen bond formed. Intermolecular hydrogen bond mean hydrogen bond formed between two different molecules. This is intermolecular hydrogen bond and this is intramolecular hydrogen bond. Okay, compared so here in orthonitrophenol, intramolecular hydrogen bond possible. Okay, so here it will be more volatile. Okay, orthonitrophenol is more volatile in nature. Okay, why it is more volatile in nature? Because there is intramolecular hydrogen bond, not intermolecular hydrogen bond. Okay, if there is intermolecular hydrogen bond, comparatively less volatile. Okay, so it is less volatile and this is more volatile. So we can separate these two isomer we can separate by steam distillation. We will use steam distillation. Why we will use steam distillation? In orthonitrophenol, intramolecular hydrogen bond formed, it is weak force comparatively, so it is easily volatile. Okay, so we can separate it easily. Okay, so here we discussed, here we are talking electrophilic substitution reaction. Okay, so here this OH will be deactivate ortho and para position. So most of the substitution takes place in ortho and para position. Here first substitution reaction we discuss nitration. Okay, first substitution reaction nitration. Okay, so here dilute nitric acid reacted with phenol, it will change to, or the product formed a mixture of ortho and para product, orthonitrophenol and para-nitrophenol. Okay, these two isomer can be separated with help of steam distillation. Why we choose steam distillation? Because orthonitrophenol intramolecular hydrogen bond easily volatile, but in para-nitrophenol there are intermolecular hydrogen bond and it is less volatile. Clear? Okay, next one we have to discuss here nitration. We already discussed nitration with dilute nitric acid. Nitration of phenol reacting with the dilute HNO3. So we will get a mixture of orthonitrophenol and para-nitrophenol. Next one we have to discuss here phenol reacting with concentrated nitric acid. Previous one dilute nitric acid, now it is concentrated nitric acid. Phenol reacted with concentrated nitric acid, we will get 2,4,6 trinitrophenol. 2,4,6. Here this is first position. Okay, 2, 3, 4. Look here, this is first position, 2, 3, 4, 5, 6. So you can see here in second 2, 4, 6. Okay, 2, 4, 6 trinitro NO2. Okay, 3 NO2. So 2, 4, 6 trinitrophenol. This is one explosive chemical. Trinitrophenol, it is explosive chemical. Okay, so here phenol reacted with concentrated nitric acid, it formed 2,4,6 trinitrophenol. Okay, this chemical reaction produce less yield of product. The product formed by this chemical reaction yield will be less. Yield mean amount of product will be less. Okay, so nowadays we will produce 2,4,6 trinitrophenol different way. Okay, first here phenol reacting with concentrated sulfuric acid, so we will get one ortho-para substituted phenol. In ortho and para position there will be SO3H. Okay, SO3H will be there. Okay, and after that this product reacting with concentrated nitric acid, we will obtain 2,4,6 trinitrophenol. So here why we do not follow this method? The product formed by this chemical reaction less yield, that's why we will follow another method here. Here phenol reacted with concentrated sulfuric acid, ortho-para substituted product will be formed. In ortho and para position there will be SO3H. After that it treating with concentrated nitric acid, we will obtain 2,4,6 trinitrophenol. 2,4,6 trinitrophenol also called picric acid. Okay, the chemical picric acid mean 2,4,6 trinitrophenol, that is picric acid. Clear? So after nitration, second chemical reaction, halogenation. In halogenation we have to study here bromination. Okay, phenol reacting with bromine. So phenol reacting with the bromine, we have to discuss here two different type of bromination. Okay, here phenol reacting with the Br2, phenol reacting with the bromine in presence of carbon disulfide, or phenol reacting with the bromine in presence of carbon disulfide or chloroform. So this chemical reaction we can here phenol reacting with the bromine. Okay, here this chemical reaction takes place in presence of CS2. CS2 means carbon disulfide, or we can use CHCl3. CHCl3 means chloroform. Okay, so after that we will get a mixture of product orthobromophenol and para-bromophenol. Okay, we will obtain a mixture of product. So this is one of the bromination. Phenol reacting with the bromine in presence of carbon disulfide or CHCl3. So we will obtain a mixture of product orthobromophenol and para-bromophenol. Second chemical reaction, second bromination. Second bromination here, phenol reacting with the bromine. Okay, here it is aqueous bromine. Aqueous bromine mean bromine water. Phenol reacted with the bromine water at room temperature, it will change to 2,4,6 tribromophenol. Same like this product, here we set 2,4,6 trinitrophenol, here it is 2,4,6 tribromophenol. So remember, phenol reacted with the bromine in presence of carbon disulfide or chloroform, orthobromophenol, para-bromophenol, a mixture of product obtained. Here phenol reacted with aqueous bromine or phenol reacted with the bromine water, we will obtain 2,4,6 tribromophenol. Clear? Okay, next one, we have to discuss here two important name reaction. We have to remember here two important name reaction, Cox reaction and Reimer-Tiemann reaction, RT reaction. Okay, Reimer-Tiemann reaction. Okay, shortly you can say RT reaction, Reimer-Tiemann reaction. So here Cox reaction mean phenol reacted with the sodium hydroxide, sodium phenoxide will be formed. This sodium phenoxide reacted with carbon dioxide in presence of acidic medium. Okay, sodium phenoxide, we know this is sodium phenoxide. Sodium phenoxide reacting with carbon dioxide in presence of acidic medium. Okay, in presence of dilute acid. Here phenol in ortho position carboxylic acid will be substitute. Okay, this is called salicylic acid. Okay, this product is called salicylic acid. Here phenol, this side COOH, this is carboxylic acid, salicylic acid. Look here, second reaction we have to discuss here. This is phenol in ortho position aldehyde. So name of this product salicylaldehyde. Here salicylic acid, salicylaldehyde. Okay, so remember Cobb's reaction product salicylic acid, Reimer-Tiemann reaction product salicylaldehyde. Both are related. Okay, so both are reacting with the sodium hydroxide, and here the product is salicylic acid and here the product is salicylaldehyde. Okay, so here first one we discuss Cobb's reaction. Cobb's reaction means phenol reacting with sodium hydroxide. Sodium phenoxide will be formed. Sodium phenoxide reacted with carbon dioxide in acidic medium, salicylic acid. Salicylic acid. Okay, so this is ortho. Here this is the main group, this is the substituted group. So you can say 1, 2. We have to give priority for carboxylic acid. This is first number, this is second number. So 2-hydroxy benzoic acid. 2-hydroxy benzoic acid. That is salicylic acid. 2-hydroxy benzoic acid, or you can say salicylic acid. This is the product of Cobb's reaction. Next one, Reimer-Tiemann reaction. Here also phenol reacting with sodium hydroxide in presence of chloroform. Okay, phenol reacting with sodium hydroxide in presence of chloroform, an intermediate product will be formed, an intermediate compound formed. Okay, here this part ONA and here CHCO2. Again this intermediate compound treated with sodium hydroxide, this part will be oxidized and changed to CHO. Okay, then followed by acidic hydrolysis, ONA changed to OH. So final product salicylaldehyde formed. Okay, ortho hydroxy, or you can say 2-hydroxy benzaldehyde. Okay, here 2-hydroxy benzoic acid, here 2-hydroxy benzaldehyde. Salicylaldehyde will be the product. So Reimer-Tiemann reaction means phenol reacted with sodium hydroxide in presence of chloroform, an intermediate product formed. This intermediate product again treated with sodium hydroxide, we will obtain this type of product, followed by acidic hydrolysis, 2-hydroxy benzaldehyde, salicylaldehyde is the product. Clear? So here we discuss Cobb's reaction and Reimer-Tiemann reaction. Okay, next one we have to discuss here phenol reacting with zinc dust. We already discussed here in phenol carbon oxygen bond breaking takes place in presence of zinc dust. Okay, we already discussed in the beginning of this video. Here in phenol, here carbon oxygen bond breaking takes place in presence of zinc or zinc dust. So here phenol reacted with zinc dust, benzene will be formed. So you can convert phenol to benzene after treating with zinc dust, zinc powder. Okay, so here zinc will be oxidized to zinc oxide. Okay, this is one chemical reaction of phenol. Another one, oxidation of phenol. Phenol after oxidation with sodium dichromate. Okay, phenol after oxidation with sodium dichromate in presence of sulfuric acid, benzoquinone will be formed. This chemical called benzoquinone. Okay, so here phenol after oxidation with sodium dichromate in presence of sulfuric acid, here this product benzoquinone will be formed. Okay, here benzoquinone will be formed. This circle, you know, it is alternate double bond. Okay, you can do it like circle. Okay, so this is benzoquinone will be formed. So these are the different chemical reactions of phenol. Okay, we have to discuss. These are the things we have to discuss in this video, chemical reactions of phenol. So here we discuss Electrophilic substitution reaction takes place in ortho and para position because here OH electron pair present in OH, it deactivate ortho and para position. We discussed nitration, two different type of nitration, halogenation, bromination, two type of bromination, okay, and we discussed Cobb's reaction, Reimer-Tiemann reaction. We discussed a conversion of phenol to benzene. Also we discussed how to convert phenol to benzoquinone, or we can say the phenol after oxidation it will change to benzoquinone. Okay, so these are the things we have to discuss in this video. Thank you for watching this channel.